Okay, let us now look at gauge transformations in the Fourier space. So gauge transformation of the metric perturbations in the Fourier space. So let us look at the metric perturbation components. We have a scalar A, D, and then let's write all the components here. Gij, delta Gij is equal to A square minus 2A minus 2BI minus 2BI. It's minus BI. Minus 2D delta Ij plus 2EIJ. Now, from gauge 1 to gauge 2, we have defined the coordinate transformation is done through gauge transformation vector. This is gauge 1, this is gauge 2, and this is the transformation vector, gauge transformation vector. Fourier expansion of this gauge transformation vector is now let us look at the perturbation of these components, gauge transformation of these perturbations in the Fourier space. These are the equations which we have seen earlier. So the scalar A transforms according to this equation. A tilde is equal to A minus xi0 0 minus h0, where this h is A prime by A, and these are the transformation equations, gauge transformation equations in for space-time. Now we would like to write the version of these equations in eta k space. So how do these equations look like in eta k space? Let us take a look. Let us start with the first one. A tilde A minus xi 0 0 minus h xi 0. Now for xi alpha, the corresponding Fourier term is xi alpha. So xi alpha is xi alpha, and for xi alpha 0, xi alpha 0, the corresponding term will be For xi alpha 0, the corresponding term will be xi alpha 0. For xi alpha I, the corresponding term will be so from here the corresponding term is xi alpha in K space. Here we have xi alpha 0 in K space, and here we have I Ki xi alpha I. These are the values in the K space. So we have A tilde in K space is A tilde, A in K space is A, xi 0 in K space is xi 0, and this xi 0 is xi 0. So this is the transformation, gauge transformation in K space, which is same as this one. This is in X space, eta X, and this is in eta K. Now next let us look at this equation. Xi I 0, xi 0 I. Xi I, 0 minus xi 0 I. This one. So we have B tilde is B tilde I in K space, and this is Bi in K space. This is xi I 0 in K space, and xi 0 I becomes this I Ki xi 0 I. I Ki xi 0. This is I. So this becomes xi 0. This in K space is D tilde, this is D, and this is this is xi 0. So we have d tilde t plus 1 by 3 plus this. Sorry, this is k. Okay, let's look at the tensor transformation, which is this equation. This is e tilde ij eij, and this is basically xi I j plus xi ji. So this would transform as xi I j I kj psi I ki psi j I kk psi k. So we have this is equal to this minus kj psi I plus ki psi j plus I by 3 delta ij kk psi k. Next, let us consider a mode k. For a given mode k, let us align the z-axis parallel to k. So we can align the z-axis parallel to k such that we have this k is parallel to z. In this scenario, let's see what each component becomes. A tilde is this will be this will remain the same under this new value of k. This remains the same, and let's see how d transforms. D would transform this will be d plus 1 by 3. When you contract on k, only the 3 k is equal to 3 will survive. So this will be k psi 3 plus h xi 0. Let's see how this transforms. So we have here k psi 3. When you contract on k, 1 and 2 will disappear because 1 and 2 components of k are 0. And here we have delta J3. This is delta I3. So starting with 1 component, 1 component will be, this will be 0, this will be 0, and this will be k psi 3. So E11 plus I by 3 k psi 3. 1 2 component, this will 1 3 component, sorry, we have k here, k here. By symmetry, this is the 2 1 component also, and this is the 3 1 component also. So we got 1 1 component, we got 1 2 component, we got 1 3 component, we got 2 1 component, 2 2 we need to find, 2 3. Let's see 2 3 component. So 3 component is this, and this is same as 3 2 component. So now we need to find 2 2 and 3 3 component. So 2 component will be this is 0, this is 0, this is KSI 3, and for 3 component tilde ij is equal to aij minus I by 2 to 2. So plus I by 3 k psi 3. This is total component. And for the 3 component, let's write 3 here. 3 minus I k psi 3 plus 3, so this becomes 1, and kk will be kk psi k will become k psi 3. So and this is delta 3 2 ik psi 3 by 3. So now we can write this transformation of delta G mu nu as delta G mu nu tilde is equal to G mu nu. This is in tilde gauge, this is in gauge 2, this is in gauge 1. Computer is also tired like me today. Okay, so now this lambda mu nu is the transformation, the components which we just calculated just now, all these components. When we collect all these components and write this matrix lambda mu nu, we will find that the components are they can be written like this. This is a calculation which I have done offline, and now in all these components you see that when you are doing the gauge transformation, the new components are added. This lambda matrix is the new matrix which is added to the previous delta G mu nu. Lambda mu nu is addition to delta G mu nu, and these components of lambda mu nu, they are added to the components of delta G mu nu. And the important thing to notice here is that none of these components is tensor. You have scalar values which are added to the this components, and then you have vector values also added to the components, but the tensor components, which is basically ET11 minus ET11, ET12 and ET12. So to this, if you look at 1 1, scalar is added. If you look at 1 2, 0, 2 1 is 0, and 2 2 2, this is 2 2, again a scalar is added. Now this scalar is added, which is added to this 1 1 and 2 2 component. In 1 1 and 2 2 component, in the original, in the metric in gauge 1, D is already present there. So we already have D, because this 1 1 component, in 1 1 component we already have minus 2D delta ij, delta ij plus 2e. And when you are adding this scalar which is coming from gauge transformation, that scalar gets added to, this is 2ij, this scalar gets added to this D. So the new scalars which are coming from this transformation, they get added to the D part here, this scalar, because this is scalar, whereas this 2eij, the tensor, that does not transform. So there is no tensor addition to this eij. So eij, the tensor component, is gauge invariant. This is etij. So etij is gauge invariant. And there is the scalar part of eij also, which is combined with the D. I'm not, I forgot to write that here, but you can go back and look at the last few minutes of the lecture. So we have the scalar part which is combined with D, scalar part coming from ET which is combined with D, and the new scalar perturbation, new scalar transformation values which are generated, they will also be combined to this scalar part here, and the tensor part is gauge invariant. Okay, so because I am tired from this is the 5th lecture I am recording in a row, so I took a break and did some calculations offline. I will be quickly presenting these facts. They are pretty much straightforward, and yeah, so If I get time in future, maybe I can redo some of these lectures in more detail. But for now, I think we can, without losing the depth of the important facts here. Most of these are pretty straightforward calculations. So let me go over this straightforward simple calculations. So we have delta H mu nu, which we have seen, and this is also we have seen that the scalar part is given by this. Scalar part is given by this Hij scalar. So Hij scalar is we have minus 2d delta ij, and this is coming from Etij scalar. Etij scalar. Sorry, not Et but Es. And when you combine when you factor out delta ij from these two terms, you end up with this term, and this term is del square E, and d plus del square E is defined as scalar perturbation xi. D plus 1 by 3 del square E. And in K space, this will be psi k dk, plus from here we will get del square will be this will be E by k square, and we will have another k square term coming after differentiating twice with a negative sign. So this will be minus 1 by 3 ek. This is in K space. Now next, in this course, the main part of our focus will be on scalar perturbations. So let us collect all the scalar perturbations that we can collect from this metric. We have seen that we have scalar perturbation A, B, and from Hij we can get D, and we can get E. From the Esij we can get E. There is another scalar perturbation which we can get by splitting this transformation vector into its this scalarless part and divergenceless part. Means this is longitudinal and this is transversal. So longitudinal and transversal part we can split scalarless and divergenceless part, and then we can use instead of the in gauge transformations, instead of using vector xi, we can write gauge transformation in terms of potential xi, not vector xi but the potential xi. That way we will be dealing with all the scalar quantities and no vector quantity at all. So the scalar content of perturbation can be retained by just expressing xi vector in terms of this xi potential. Now when we do this, then let's see what is xi vector. Xi vector is xi 0 and xi xi alpha. Yeah, xi alpha is xi 0 xi vector, where xi vector is now broken into two components, decomposed into two components, scalarless and divergenceless. So from xi alpha, from x alpha, x, this is gauge 2 and this is gauge 1. We have this. So we have this and xi plus xi, this is xi I, and xi I is written in terms of this component. Gradient is written in terms of gradient. This is xi I, this part, scalarless part of curless part of xi. This is the curless part of xi, curless part. So if we write this transformation vector like this, and which means xi I, if we write like this, then let us see how does it affect the transformation equations. We have the first transformation equation is transformation of scalar a tilde xi 0, we have xi 0, so no change. How bi vector transformation is impacted? In bi tilde, now we will replace this bi tilde with the negative of gradient. This is also replaced with negative of gradient, and this is also replaced with negative of gradient. So when we do this, this xi 0 will be kept as it is, but others will be replaced with negative of gradient. So when we do all this, we will get this. Now let's see how this is impacted. See how this is impacted. Again, d tilde is d tilde, d is d, but ek I am now going to express in terms of its gradient, and when we differentiate that with k, this becomes del square e minus del square e. So this is basically minus del square, not e but xi, minus del square xi. So this becomes this. Okay. Now let us see e tilde, how e tilde changes. Now e tilde ij, I'm going to write like this. That is how scalar is defined. This is basically the scalar part of these two. Once I write this in terms of scalar part of these two, and then this I write this. So this becomes this, and this becomes eij minus 1 by 3 delta ij del square e, right? Plus, and this term is here. This term is here. Plus half. So how do we get these terms? xi I with respect to j, and xi I with respect to j is this, and this is basically del square xi. So when we write it like this, we can see that we can very easily see that we will get E tilde ij minus 1 by 3 delta ij del square E tilde is equal to E plus xi ij minus 1 by 3 delta ij del square E plus xi. Therefore, you can see that so this is like this. So you can see that what you can see here, you can see basically this is delta I delta so you have this operator del minus 1 by 3 del ij del square of E tilde so E tilde is equal to E plus xi. Next is that we have this now scalar perturbation gauge transformation of scalar perturbations. That is what we just saw, that when you do the gauge transformation of scalar perturbations, the equations look like this. And by the way, this equation is very simple. Once you have derived all the big equations for gauge transformation, scalar perturbations of gauge transformation of scalar perturbation, this is pretty straightforward. And where this psi is defined like this, d plus 1 by 3 del square E, where psi is d plus 1 by 3 del square E, d plus 1 by 3 del square E. Basically, in order to come to this equation, all you need to do is that write psi prime in terms of this, d prime plus 1 by 3 del square E prime. Now write d prime in terms of d, E prime in terms of E and psi, d prime in terms of d and psi, E prime in terms of E and psi, and we will get this equation. Now what we want to do is that from these three equations, I want to eliminate psi, eliminate xi. And when we eliminate xi from these three equations, then we will get see here we have two variables, xi and xi0, and three equations. So when I eliminate xi from here, then the relationship that I will get will be independent of xi, and that relationship will be the relationship of gauge invariant terms, because I am eliminating xi. Xi is basically gauge transformation vector. So any expression, any equation that does not contain xi will be gauge independent here. So let us see how we can eliminate xi. So I can say this is, let's say this is 1, this is 2, and this is 3. Okay, so I can say I can straight away eliminate this xi from here. I can put xi is equal to e tilde minus e. So I will get d tilde is equal to d minus 1 by 3 del square e tilde minus e plus h xi0. Now what is xi0? Xi0 is b tilde minus b minus e prime, b tilde minus b tilde minus b minus xi prime. So I will get d tilde plus 1 by 3 del square e prime is equal to d plus 1 by 3 del square e plus h b tilde minus b minus h xi prime. Xi prime is e tilde prime minus e prime. Xi prime is e tilde prime minus e prime. Now if we move the terms, if we keep one gauge term on one side and second gauge term on the other side, we will get d plus 1 by 3 del square e minus hb plus h e prime is equal to same terms on the right hand side but with tilde. So you see that this term is gauge invariant. So we have whatever we have on the left hand side, the same thing is on the right hand side but with the tilde sign. So this term on the left hand side is gauge invariant. So this capital psi, we can call this capital psi, it is gauge invariant. D plus 1 by 3 del square E plus H E prime minus B. This is gauge invariant. Gauge invariant. So in gauge transformation, this quantity remains fixed. Now let us look for one more quantity which is gauge invariant, because we are eliminating two variables here, xi0 and xi, but we have more than two equations. So let us see if we can use a tilde equation also. Can we use a tilde equation? What is a tilde? A tilde is this. Let us see if we can use this a tilde equation also. And by the way, this is d plus 1 by 3 del square E is small psi. Curvature perturbation. This is curvature perturbation. Okay, now coming to the next gauge invariant quantity that we can derive from here. We have these equations. So from these four equations, what else we can derive? Now I have xi 0 is here. Okay, so xi 0 prime. Yeah, I can eliminate xi 0 from here, and I can put so sorry, yeah, yes. So from these two I can first eliminate xi. So when I eliminate xi from these two, what do I get? I get d tilde is equal to d minus 1 by 3 del square E tilde minus E plus H xi 0. Now get H xi 0 from here. So what I can do is that I can get H xi 0 from here, or maybe you know what, what's the best way? So I will get E0 prime. Yeah, so one way to do this is that I can yeah, so one way to do this is that I can write I can add these two, and I will get A tilde plus D tilde is equal to A plus D minus 1 by 3 del square xi minus xi 0 prime. Is it right? Or I don't need to do that basically. No, I didn't like that. I think what we can do now is that eliminate xi 0 from here, find xi 0 and put the value there, here. So what is xi 0? Xi 0 is 2, or hang on, there is another trick which we can use that would be much simpler. Yeah. So what we can do is that if that equation will be much simpler than the one which we were dealing with. If I substitute xi from here to here, I will get b tilde is equal to b plus E tilde xi minus E xi E tilde minus E xi plus xi 0. This is much simpler to deal with. Now put the value of xi 0 from here to there. We will get A tilde is equal to A minus xi 0 prime. So what is xi 0? B tilde minus B tilde prime minus B prime minus E tilde minus E double prime, this minus H E0 is B tilde minus B minus E tilde minus E prime. So what do we get here? If we collect the terms of one gauge, on one side we have A, then we have B prime, then we have A plus B prime plus sorry, this is minus plus minus E double prime plus H B negative, and this is negative minus H E prime, and then the same quantity but with tilde sign on right hand side. So we have A plus B prime minus E prime B minus E prime plus H B minus E prime is equal to same thing but with tilde sign. So this quantity is called phi, big phi. It is called A plus H B minus E prime plus B minus E prime, and this is also gauge invariant. So we have looked at two scalar perturbations which are gauge invariant. One is this one, big psi, which is equal to this. Second is this one, big phi, which is equal to this, and these two are called Bardeen potentials. The beauty of Bardeen potentials is that they are gauge invariant. Thank you guys. See you later. Bye.